Electric vehicles and e-mobility are very important trends worldwide. In Germany, not only is electric mobility a central part of the government's climate policy, the German automotive industry is also the biggest investor in electric vehicles globally. I am your host Paras Mehta, and today on India to Germany, we speak with Athar Khan about his experience as a mechanical engineer working in e-mobility in Germany. Athar is a specialist in vehicle component testing and currently leads projects in the area of electric vehicle powertrain at Value Siemens in Bavaria, Germany. He has 15 years of experience working for the automotive sector in Germany as well as in India. Welcome, Athar. Thank you for speaking with us.
Thank you, Paras. It's really a pleasure to be here.
So, Athar, you are working in the area of electric mobility, which is a very important topic these days. So, what does Value Siemens do, and what is your work at Value Siemens about?
Yes, Paras. So electric mobility definitely is a big thing these days, and that definitely is what actually made me come into this field. And Value Siemens is also a very so it's a new player, but it's a very important player in the field of electric mobility. It's a tier one supplier, and we basically make customer specific high voltage components. And so we are not doing any low voltage electric mobility, but only focusing on the high voltage, so something like 400 volts or plus. And we basically make system or sometimes make so we make systems or we make components. When you talk about systems, it's more like a combination of an e-motor with a inverter and a reduction gear, and this is basically sold as an e-axle. And we supply this to the customers and apply them or integrate them in their vehicles and make it according to their requirements. And this is what we do for as Value Siemens. And talking about my work at Value Siemens, I'm working as a technical project manager for an e-axle development project. And as a technical project manager, I have a team of around 50 engineers who are working in different areas of research and development. So that is design, simulation, testing. So design includes both electrical as well as mechanical design, simulation as well. And for testing also, we have variety of tests from functional to environmental, and then finally the homologation tests. As such, the team is spread all over the continent. So it's again very, and especially this topic is being held, or this topic is relevant not only for Europe or Germany, it's relevant all over the world. And that's why we have also team spread all over the world, and we are working together. So one of my major role as a technical project manager is also coordinate this communication between the different set of teams working across the world. So yeah, this is what I do as a technical project manager.
You also mentioned e-axle development. Perhaps you could also give us some examples of the kind of projects that you lead as a technical project manager.
Yeah. Generally, the projects in e-axle development, they are so complex, and the requirements of the customers are so varied. So generally, we as technical project managers, we try to concentrate on single projects or projects which are very close to each other or on the same platform. So my project is currently for an OEM, a European OEM, and it's for a luxury and a sports car version of that luxury vehicle, and it can have torque up to 1100 Newton meters. So you can imagine it's quite a powerful vehicle that we are working on. And so what my work basically starts from the phase where we are going through the acquisition of the project, and then kind of developing a concept, and then trying to bring that concept into more designing and simulation kind of phase, then going through the whole development at the supplier, or maybe at internally if we have to set up some lines, so development with the internal manufacturing, and then finally some kind of testing. So this is what most of my work really revolves on. And the most of the projects that we work on, as I told you, it's about either as an e-axle or components. And one of the component that I take care of is the e-motor development itself, which is also a very important component of the e-axle. And you have in the e-motor, if you go into the designing or designing part of it, it is partly mechanical because of all the laminations and the rotor that you have in there. Plus then it has a very big portion which is electrical, that is the design is electrical. For example, the windings, the way the windings are to be done. So it's really a complex system in there. And the projects are generally, as I told you, are done very customized for the requirements that the customer gives us. And from our side, we try to come as much forward in the technology as possible, because there is a lot of development going on in this field. And right now the trends are not so sure in which directions each will go. So we always try to bring kind of ideas, new ideas, and then try to develop it together with the customer according to his requirement.
So it's interesting that you mentioned that there are a lot of new developments that are going on in this area.
Hmm.
I also keep reading, yeah, that the German car makers are investing heavily in e-mobility at the moment. So perhaps you could tell us a bit about some of the current trends in this area.
Yeah, so the point is like these trends currently that we are seeing are being pushed by, I think, the three important factors. One of them is the legislation itself. So you have probably would have heard about the Paris Agreement, and how the CO2 targets have to be met by countries, companies, so everyone across the world. So with that, a lot of governments across the world are pushing for kind of reducing their dependence on combustion vehicles, and that's why they are planning to ban a lot of them. I think India is also trying. It has not given a date, but Germany also is in the same boat. But for example, UK, it's like they have given a date of 2040, which they are trying to bring to 2030 now. And there are many other countries across the world which are trying to do that. So that is one part which is pushing the trends that we are seeing right now, that a lot of investment is happening from the OEMs and tier ones and tier twos in this electric mobility field. Then also I would like to talk about the part that the technology that is pushing forward. So we see that the cars have been there around for more than 100 years, but and the development that we have seen, for example, in a market for a mobile, it is very different, and it has grown much more exponentially. When you see it, for example, you had in 2007 the first iPhone, and now the phones are totally different from what we had that time. So but this kind of explosion or kind of explosive growth has not been seen in the automotive industry. So now there's kind of a roadmap which is prepared with a lot of minds coming together of the automobile industry, and they are working on this something that a lot of people will hear of is called CASE, which is like it's an acronym for Connected Autonomous Shared Electric Mobility, which is kind of all the current trends that we are seeing in the automobile industry are in those fields. So these four fields are the current fields which are ongoing. When I come to, let's say, only the electric, or look at only the electric vehicles, there is a push that have been there, especially after 2015, after the Volkswagen Dieselgate episode. There has been a very strong push towards the electric vehicles. And at that time, like when you go back to 2015, in the in automotive world, there was talk about hybrids a lot, but that has been kind of pushed a little bit on the sidelines, and there's a very strong push towards full electric vehicles. And that's why you see a lot of trends trying to go, a lot of companies, they are coming with the full electric vehicles rather than not going and relying on hybrids, because they're going to be only partly there, as I talked about the legislation of banning the combustion vehicles. Another important trend that is going on is about the voltage. So normal vehicles that we have generally on the road, they are working on a 12 volt or a 24-volt architecture. And now with the hybrids, the architecture is moving towards 48-volt. And when you talk about electric vehicles or a full electric vehicle, there's nothing under 200, 250, or they're generally like 400 volts. And that's where the high voltage starts. And now this trend is also going towards 800-volt, which is coming from the needs of for us to have fast charging, and to have more, let's say, possibility of having more power with a smaller battery. And this is what is kind of pushing. Also, this is one of the other trends that we are seeing in the industry. When you look at trend from the industry point of view, so what is also not very clear is like where the OEMs and the tier ones are going, because right now each OEM has their own strategy whether to go alone. Like for example, Audi has done that and shown with an e-tron. But when you look at some other OEMs like Volkswagen, they have very strong partnerships with the tier ones. Same way with other big OEMs in the German market. Also talking about outside Germany, like China or India, most of the OEMs, they are trying to go with different strategies. So what is not clear right now is that whether this strategy would hold on, because a lot of people are working in those OEMs as well. So if they start relying only on tier one for their supplies, so what will happen to those people? So there is kind of a change in strategy which might be seen as like OEMs trying to buy those parts individually and then put it together themselves or assemble it themselves. So there is also a very not clear part. What we are also seeing is about the infrastructure that has to be built up, because the trends that we are seeing right now in electric mobility will completely fail if there's not enough robust infrastructure available for the high volt charging, and also the density of the charging stations, so that people don't have the stress of driving a car when they think like, okay, their charge is going to run out. Because normally when you are driving with a petrol car or a diesel car, you don't really have to think about looking at your range all the time. So it's kind of these points that I mentioned, they are kind of defining the trends in the industry. So it's going to be a very interesting time in the automobile industry, especially for electric mobility, and for other parts like the connected cars, the autonomous cars, and shared mobility. This is also kind of combined together, because it's always, when you talk about electric cars, they are much more simpler than the cars that we have currently. They are more easy to connect, control. So all in all, it kind of helps to justifies the case of bringing this connected cars and autonomous cars. So this, I think, is going to be the trend that we're going to see in the next few years in the industry.
Great. That sounds very interesting. It's also very nice that you kind of classified this into sort of new developments based on the because of changes in the legislation, or also the developments in the technology and the infrastructure. I think it's a very, very good overview. So, in order to kind of keep up with these new developments, if let's say someone wants to find a job in the area of e-mobility, what do you think are some of the important skills needed to work in this area?
I think the skills definitely are going to be not like one core sector. Like, generally, if you go back 10, 15 years in automobile industry, it was all about mechanical or maybe an automotive engineer. But now it is more kind of a combination of all the engineering backgrounds that we have. So, as I talked about, my team itself, when I think about it, has people doing having a big background of mechanical engineering, industrial engineering. There are electronics, electricals, computers. So it's combination of all those engineers who are coming together in the teams, and this is gonna be the case. So and I think the skill would be, I always think is gonna be what a person can do well becomes a skill. So whether if they are right now a good designer in mechanical industry or an or a core combustion engine industry right now, they can always move into those kind of areas and look into designing field or designing jobs that they have. So that is those are the skills I would say for engineering point of view. But like when I talk about my point my when I talk about my job as a technical project manager, this is kind of a combination of engineering and management. And when you look at the management point of view, one has to have good project management skills, understand how the quality management works, and should be have a very strong aptitude for problem solving. So maybe use of tools like FDA, Ishikawa, 8D reports, and since you have a very big team, you need to have good communication skills and definitely very good people management. And depending upon where you work, I think language plays a very important role. And especially with the kind of people you're working in the team, and also with the kind of customers that you're working with. So, in my case, that has been also, for example, German. So, German knowledge was definitely a very important skill that one needs to have, at least to grow higher in the industry. Of course, yeah, as an expert, you probably might not need that much of German. If you go into more core engineering field, you probably do not need that much amount of German. But when you look into kind of a management field, or you're looking at a leader position, then German probably would become an important factor when you talk about jobs in Germany.
Okay, yeah, that's a very good advice. That learning German is definitely has a lot of advantages. It's also very interesting that you say that traditionally, automotive industry was more about mechanical engineers or people with a mechanical engineering background, but now this has kind of become much broader, and now people with many other skill sets are also kind of in demand in the automotive sector. Um,
Yeah, that's definitely the case. I mean, especially with the software industry right now, and as I talked about the trends that we are seeing, the connected cars or autonomous cars, there's nothing which can happen without a software developer there. I mean, actually it's a trivia. When I was working with my previous company, it's a trivia that we used to always talk about. The amount of codes, lines of codes that we have in a car is much more than any computer that you have or any laptop that you have. So it does not the amount of software development that is going in there is much more than in a computer.
and before starting in your current job at Value Siemens, you were working in a different area on combustion engines. So, could you tell us a bit about your background?
So yeah, so basically talking about myself. So yeah, I was born and did my schooling in Bhopal, which is in Madhya Pradesh, and from there onwards, I always tried to look into developing my skills and or more wider variety of skills. And what I saw in Bhopal itself was being a, let's say, a kind of smaller town or a smaller city. The opportunities were limited, and I wanted to broaden my horizon. So I decided to do my engineering somewhere, at least a bigger city. And in fact, for that, I even did not take up an ITs and try to go into some kind a private institute, but one of the best ones in Bangalore, and did my mechanical engineering there. And during that time, I was, let's say, that was the time that I got bit by this automotive bug. And I was in mechanical, and I have, no, but then automotive was something which was there back of my mind. But once I was getting involved, or once I started getting involved with some projects like a mini Baja, which is, I think, kind of rage right now. I think, but way back in 2004 and five, when I started doing this, it was one of the only colleges which was doing it. So we started building a car from scratch. We were a group of 11 engineers in our undergrad engineers, and we tried to work on different parts of an kind of a business you will have as an automotive business. Some people are working on marketing, some people are working on manufacturing and R&D. So I was a part of this R&D manufacturing team trying to build a car from scratch. And we were able to build a car in around 1 year, and the project lasted around 1.5 years. And we competed with or represented India along with NIT and DCE in 2006, which was like one of the few first colleges to go and compete in an international competition. And at that year was kind of a change year when the Baha kind of exploded into the scene. And in 2007 there was a Baha in India, and that kind of changed a lot of for a lot of people in automotive engineers or automotive enthusiasts in India, who started going into automotive field, and especially in taking part in mini Baha. And I think this exposure that I have let me go towards an core automotive company, which was Ashok Leyland. And I started there as a GET, which was kind of a training period where I must say that the training that I got there was one of the best that I have gone seen anywhere. And we had like core automotive training, because as you know, there is a huge gap currently in our education system and the industry with the needs. And that's where a good company like Ashok Leyland tries to fill the gap and tries to make these mechanical engineers more suitable for the automotive field. And that's where I was working on real time projects. And that's where I was able to learn the whole product development process, starting from the concept to the homologation phase. And I started as a designer there, so working on Pro E, CATIA, and then doing some CAE work with ANSYS and SolidWorks. And that's where I started picking up skills. Designed for one of my first components. It was a gear train, and then developed that gear train with the suppliers. So kind of developed this supplier development skill, let's say. And then once this was developed and prototype was ready, I took care of an application for one of the vehicles, and also did the testing. So it was kind of more broad based. But what I definitely learned during this time was kind of tech expertise that I had in during this time was very limited, or very novice. And that's where I decided, okay, I need to do some kind of a master's in a field where I would like to see myself working later. And that's where I decided, okay, it has to be automotive, because I have had already 3 years of experience. And then was a question always, which normally as an Indian you have is, okay, are you going to UK, US, or Australia or something, or are you going to think of something else? And automotive, as you know, is one of the highest points that we have for Germany, or the sector which is one of the most advanced in Germany. And RWTH, as well as the cost factor, they played all a role, and that kind of pushed me towards coming to Germany at that time. Then when I came here, I realized, okay, automotive is a very, very wide field. And that's where I was kind of fascinated towards how kind of interface between the human and the car is, and the kind, not the one that we just see, but something which is more technical part of it, that is the calibration. So what I was working on was kind of developing these complex models of the engines, which can be used for calibration of cars, so that they are running as smoothly as they are running in the field at the end. So a general project for me would start like, I would just get kind of factors or kind of requirements from the customer. They will say, okay, they need to meet kind of a Euro 6 norm or Euro 5 norm or whatever, and what kind of CO2 targets they have. So based on that, I will try to model what kind of what kind of or what amount of fuel at what time, at what pressure, what kind of air, quantity of air. So all those kind of complex modeling will be put in my engine model prepared on MATLAB, and those would be kind of used for preparing the first calibrations. And this is kind of also gave me another additional skill which I talked about. It was like designing CAE, then kind of calibration skill. um, this is what I learned, let's say, as a majorly during my time at RWTH, and also as a student at FEV. And once I passed out, I started with Delphi. I think it's also quite a well-known supplier from US. And it's working on right now in the powertrain field, working for fuel injection equipment. And we were a supplier for a German OEM for fuel equipment, along with the ECU and the software required for it. And and that's where I had to decide, okay, whether I'm gonna take up the skills that I have learned, or am I gonna develop a new skill. And the what I had learned, or what I had realized during this time is was that uh, uh, these kind of skills, they are nice, but what I wanted to have was a little bit more hands-on experience. And that's where I decided to start with testing. And I think that was the first time I really got into testing in a big way, and start developing testing as my core competence. And um, and I slowly moved on from being a test engineer to a lead test engineer, and also to a then and then combined my skill as a testing and the kind of calibration as an application engineer. So that's how I moved around before I started with Value Siemens. And so I worked before came to Value Siemens. I worked for almost 10 years, and in variety of fields, in variety of jobs, from designer to CA engineer, to a testing engineer. And so it was kind of a mixed package that I had all this time.
So you already had worked in a variety of jobs for around 10 years, and then you decided to move into electric mobility. Why did you decide to make this transition?
It's a very good question, Paras. So, yeah, and the switch that I made was in 2017, or like let's say end of 2016, was I was sure about it. And I think the biggest factor I would say is what happened in 2015 about the Dieselgate, that actually changed the whole outlook of the automobile industry. Europe, since 2007, 2000 or 2006, has kind of all the European OEMs, they had kind of planned that they're going to meet all the targets for the emissions with diesel engines, because the kind of improvement they were showing with the SCR and EGR coming into play. So and especially the OBD. So all these put together, they were already kind of fixed on this. But then 2015, with this Dieselgate happening, and when it was like, okay, the targets are maybe are met, but they are not really met, because it's kind of a cheating going on there. So it was that's where a lot of OEMs kind of decided and kind of took notice of another forgotten field, that was electrical vehicles. And that's where they started spending quite huge amounts of money. And that's where the one of the first projects started picking up. So 2016-17, the first project started picking up. Of course, there was a Tesla which was already trying to come and make a name for itself. There was companies like Nissan which were doing Leaf all the time, but nobody was really taking notice of them. Or let's say they were being they were looked into, but with like, okay, yeah, they are trying, they are innovating, but they're not something gonna be for the real world. But this 2015 Dieselgate kind of changed everything, and the spending that was going into the projects was for the electrical vehicles was huge. And when you have huge spending, then you have definitely a lot of innovation and a lot of new stuff which are available. And I am always open to learning something new. And that's where I said, okay, I think for me it's clear now that I have to move and make the switch towards electrical vehicles. And I didn't want to really wait that long. And I was kind of seeing that it's gonna be a change, a switch, which each and every one who's working in the industry for combustion vehicles has to make at some point of time. And I decided, okay, I want to be an early mover and maybe take an advantage there.
Great. So you basically took this difficult situation and saw an opportunity in it to move to this new field.
Yeah, definitely.
And how would you describe your experience so far?
Okay, electrical vehicles is definitely a field not for the faint-hearted, because the problem is that normally an automotive project is generally based on some kind of platforms which have been developed and improved over a long period of time. This generally makes the project for 3 or 4 years. It's a kind of a time you have for a general automotive project, and this project time is generally okay for developing something which is already have a platform, a robust platform, and kind of an improvement on that. But when you come to electrical engineering, as I talked about, like there was not so much of development going on in most of the OEMs, and they suddenly started spending over there, and that's where the they kind of, or the higher management, it expected that the projects have to be done in the same way that we have been doing in 3 or 4 years, but you have to basically develop something from scratch, because most of the OEMs did not have anything, or even the tier ones which are kind of coming in right now or opening their shops or trying to get into the fields, they do not have any kind of platform available which they can work on, and I think that's where this whole experience made it very exciting, but it's really stressful at the same time, because you are always kind of fighting with the problems that you never expected, because nobody has done them before, nobody has seen them before. You need to do a lot in that short period of time. Secondly, there is of course a very strong pressure from the government, from the OEMs, from the tier ones. Everyone is kind of working on this, and that's why the stakes are really high. And I think the German automotive industry, its survival actually hangs on this right now, because if they do not pick up, then the kind of ease that we are awaiting for an autonomous vehicle to come would be reduced. So all these kind of are revolving around this electric mobility field, and that's why the amount of money that is going in here right now is huge. And but at the same time, the expectations from the industry, from each and every employee, is also huge. And at the same time, the number of people that are working in the industry is still minimum. It's like the most of the people, they either have an automotive background, who or they have started to make the switch like me, or they have this background from electrical engineering, probably working in some kind of on industry level for, let's say, Siemens or GE or something like that. And those kind of people, they do not have the kind of agility which automotive field requires. So it's this coming together of these two different cultures or mindsets is also makes the whole work really yeah, exciting and stressful and chaotic at the same time. But I think I've grown to enjoy this, and kind of I'm feeding off the stress that is there. So it's I think it's a roller coaster, but I think I'm enjoying all this way.
Okay, so that sounds like there are really a lot of differences between, yeah, this conventional automotive industry and this new electric vehicle industry. I can imagine this transition was not easy for you, or was it?
It's, I would say, in German, as they say it, jein. So it's like it's a really a mix, because I think when one important thing or one important decision that I took when I tried to make the switch was try to rely on my skills that I learned, and a kind of core skill that I developed, that was testing. So when I moved into the industry in electrical vehicle industry, I relied on that as a ladder to come inside, and then I used my skills that I've learned over the period of 10 years, and then started applying those to started going up in the industry. But the switch, which was the first phase, I started as a test manager or a validation manager, and this kind of helped me to bring, in the electrical vehicle industry, there were not so many people who are expert on automotive testing. So I brought this expertise inside, and that kind of made it easy from my point of view. Kind of, I was like an expert for them, who was bringing, okay, what kind of tests are there, what kind of tests can be done where, and though, and knowledge of different test houses where it can be done, and all those kind of, I that's what I brought on the table. And that was, at that time, I think automotive industry or electrical vehicle industry was looking for. And this kind of made it, for me, yeah, easier uh, to at least switch. But of course, when I came to the industry, I realized, okay, you definitely have the torque and power, but the torque and power has nothing to do with the consumption that you were talking about. You're talking about here consumption in total different units. So this had to, I had to of course try to brush up my electrical vehicle knowledge or electrical engineering knowledge. And what I did definitely was not to try to kind of go and re-engineer myself as an electrical engineer or learn a whole new field. But I tried to stick on to my skills that I had, the competencies that I had, and try to see where I find a fix for those fields or where I find the fix for those skills that I have in the field that we have, or the jobs that were available.
So you didn't try to kind of reinvent your entire skill set, but see where your skill set kind of fits into this new environment, let's say.
Yeah, that's right.
Uh, and in hindsight, would you think this was a good decision for you? And would you recommend it to other people to move to electric vehicle industry?
For me, I would say personally that this has rolled out as a good decision. I mean, I don't know if it was because of the skill set that I developed during the time as a conventional automotive engineer, but definitely this testing wasn't played to my advantage, and I was able to use this advantage to later on move on to become a technical project manager, where I use my designer CAE and all the skills that I learned all the way back since 2007. I kind of used all those skills, and I could use this. So definitely for me this was a good decision. And when I say for recommendation, of course for me, I think it's never too late to make the switch and try to come into the industry, because I think this industry requires a lot of people, especially if they have worked in automotive field and they kind of bring the skills that they have learned, whether it is testing engineers, whether they are design engineers who have worked in core mechanical design. Because at the end of the day, your motor is partly mechanical. You have mechanical components which needs to be developed, which needs to be designed, and you have the same GD&Ts, the same kind of tolerances that come into play, the same kind of mechanical simulations that need to be run. So all these things are relevant, and they're going to stay relevant. And people who are going to stay make the switch, I would say that they should not always just think about upskilling themselves or trying a complete new, learning a new field. But I would say that they should try to hone their skills and try to find a fit that they have, because I think that is also a target which most of the OEMs right now looking into, that because they have a huge personal or human resources which have been working year long or year for a very long time in conventional automotive industry producing combustion engines. And now suddenly they need to make the switch, so they cannot fire all those 600,000 or I don't know, 500,000 people, but they will try to find a match for those people into the industry. And I think this is where people can, who have already those skills, can also try and join. And maybe this would give them also a good opportunity to find jobs in the companies of their choices. And this is definitely not something I would say that you should uh, wait and think. I think is the right time. Make the switch. You have to adapt naturally, but you will. I think on in the long way you will learn. And yeah, I think as when you talk about what kind of tips or recommendations I can give, is definitely that it's good to have programming skills. I did learn those, and I think they are definitely useful. Whether you are working as a core mechanical engineer or anything, you need some kind of programming or coding skills. They always are useful. Even in your daily life, they make your work much more easier. what I would say is that when you are trying to come into automotive field, and if you are not, like, let's say, finding a fit in electrical vehicles, but there are other three topics that I talked about. That was the connected mobility or shared mobility, and also the autonomous vehicles. So all these three fields are also very hot right now. They need people, and they need people especially coming from the automotive background. And if you have the skills, whether it is software skills together with some automotive skills, you can come into the industry. You are electrical engineer, you are electronics engineer. You need each and every kind of engineer in this field.
And from your experience, I mean, I'm sure many of our listeners would be interested in working in this industry, since there is so much going on and there is so much demand also. uh, what do you think are some of the career options for people with a mechanical engineering background in the electric vehicle industry in Germany?
Mhm. Um, I think electrical or mechanical engineers, they themselves, or let me start again. So mechanical engineering itself is a very wide field. I mean, you have engineers who are working on heat and mass transfer. You have engineers working on pure kind of tolerances, and kind of checking those tolerances, and those kind of areas. So you have a very huge wide field, and you have robotics, you have industrial engineering. So with this wide field, I'm sure there are so many different kind of mechanical engineers who are available, and these engineers, they would find a fit. I mean, I for to name a few, I would say, for example, a normal designer who has done mechanical designing can become a hardware designer for the non-active parts, like the laminations, the housings that are there, the different cooling parts, and all. So those kind of parts, they require a hardware designer, so they can join those kind of fields. Then there is also a supplier development. I mean, nobody, or no OEM or a tier 1 supplier or tier 2 supplier can survive without any further suppliers. And so you always need kind of suppliers who can work, or some supplier development engineers who can work on the development activities at the supplier end. Or even, and when you talk about the manufacturing, whether you are in kind of developing an in-house manufacturing, you need certain process engineers who can develop the processes that would require to develop the parts that have been designed. And also, the hardware designers or hardware design components, they need to go through some kind of simulations. So even the simulation engineers, or the German Berechnung engineers, they can always come into the simulation engineering field, and they can work on a variety of, like, you have structural, you have fluid, you have thermal. These areas of simulation are non-electrical. You don't need so much of electrical engineering background there. You can work in those. And one a very interesting area is also material science. I know this is a little bit of an expertise area, and but this is also where a lot of work has been done in automotive field in terms of material sciences. I mean, when you think about, components inside a combustion engine, where you have temperatures up to 700 to 1000 degrees C, you would not think about some plastic going in there. But there are components, a lot of components in the engine which are made of plastic. And those kind of changes have not been done in the industry right now, in the electrical industry, because nobody had the time to do that. But a kind of material science engineers who have already worked, they might be able to help this industry grow in that direction. And of course, the field, one of my favorites, testing. You have variety of tests, whether it is functional or environmental. Maybe a functional, you might have to brush up your engineering, electrical engineering knowledge a little bit. But a mechanical test, for example, torsion tests, which each and every e-axle or an engineering electrical vehicle has to go through. You, as a mechanical engineer, has a good background in that. You can definitely kind of understand those tests and try to do those testing, or develop the concept of those testing. You have also application engineering, which is kind of combination of calibration, designing, and coming together of all the fields. And this is also a factor where, because you at the end have to apply an electrical vehicle or an e-axle on an electrical vehicle. And when it comes to vehicle, you bring your vehicle engineering skills, and as an application engineer, and use the same skills here. And coming to a little bit, let's say, non-engineering areas where also a lot of mechanical engineers can work, is definitely project management, quality management. Then you have plant development, and there I would like to point out. I mean, this is no secret. I mean. Elon Musk has been putting it on the Twitter all the time. I mean, Tesla is looking for people in plant development in Berlin, so people should definitely look if they're trying to thinking of making the switch. I think this is the right time to do that. And in the next years, there's going to be a huge development coming in the battery area, where going to be a lot of new factories, gigafactories as they call it, going to be coming up around Germany and in Europe. I think that's where the industrial engineers and plant development engineers or process engineers will be definitely required. And this kind of skills are something that we learn as mechanical engineers. So these are few of the areas that I've talked about can be used by the engineers to make this switch.
Great. That sounds like a lot of different options. It's great to be in this field at the moment.
Yeah,
Um,
definitely.
yeah. And specifically at Value Siemens, do you have any opportunities that you would recommend to people who are looking to work there?
Yeah, I think in Value Siemens, they're looking for new people. Testing is one of the fields that they're looking for. Project management, mechanical lead engineers, who kind of take care of designing as well as ensuring that the guys who take care of the construction, they are working on those activities, as well as taking care of the supplier development activities. So kind of a lead mechanical engineers, system integrators, and this is not only Value Siemens. I'm talking about the whole electrical vehicle industry as such, whether it's OEM. Yeah, maybe a little bit tougher because of as I talked about the switch that they have to do for the existing employees from conventional automotive industry to the electrical industry. Uh, those people, I think, would be given a preference, but yes, there is a chance. But a lot of new suppliers, they are developing new products in this area, and they're coming up, whether it's Conti, Scheffler, ZF. And there are to name a few, but there are various new players coming into the field. Nidec is there. I mean, uh, just naming a few. But if you look into right now in a job site, you will definitely find so many more tier one suppliers who are working for automotive industry or electrical industry. They're coming in and trying their luck in the electrical vehicle industry.
Thank you very much for sharing all your experience, your knowledge, your insights with us on this exciting topic of e-mobility, Athar.
Thank you, Paras, for inviting me. I think it was a great pleasure talking to you.
That's all, folks. Remember to subscribe to our podcast and check out our blog on indiatogermany.com. See you in the next episode.